Hello everyone, this is Poornima Deepthi working as an assistant professor in the Department of ECE at MLR Institute of Technology. Today's presentation is about Introduction to Microcontrollers. This video is a part of microprocessors and microcontrollers. Until now we have completed microprocessors. So now Introduction to the microcontrollers. Coming to the overview of today's presentation. So what is a microcontroller, where we can use this microcontroller, why we are using these microcontrollers, and what is the basic differences between microprocessors and controllers, and what is the basic block diagram of a microcontroller, how microcontrollers has been classified, and what is the overview of 8051 microcontroller, and where we can applications of the microcontrollers. So coming to the introduction to microcontroller. So what is a microcontroller? A micro means small, controller which controls the things. So microcontrollers. So micro means a small. So microcontroller is a small chip which can control all the applications of the specific processor. So here a microcontroller is a general purpose device. It is an IC. So it means to perform all the calculations, but like the microprocessor. So we can say that microcontroller is a microprocessor with having internal memory and input-output devices. So actually I have already told you, in the microprocessors, it is not having any internal memory or input-output devices. If we are considering the microcontroller, suppose if this is the microcontroller, in the same chip, it is having input-output ports, so which can take the data from the output sources, and it can present the data to the output peripheral devices, and it is having the internal memory along with the CPU, like along with the processor. So microcontroller is a, you can say that microcontroller is a computer on a chip. So single chip can be used as a mini computer. So it can take the input outputs, it can perform, it can store the data or the program in single chip, and it can process the thing. So it can perform any operations so within the chip itself. So you can say that a microcontroller is a mini computer or computer on a chip. So it is having, so basically microcontrollers support Harvard architecture. So what is Harvard architecture? So Harvard architecture is the architecture that supports the different memories for different data and program. So initially in microprocessors, normally microprocessor which we have learned is a 8086. So in that particular microprocessor, it supports the von Neumann architecture. What is von Neumann architecture means? It's the memory which we are using to store the data or to store the program is the same memory. So same memory is used to store the data as well as the program. But in the case of these microcontrollers, so it supports, most of the microcontrollers will support the Harvard architecture, which means it is having RAM, random access memory, and ROM, read-only memory. So ROM is used to store the program, whereas RAM is used to store the data. So what is the program and what is the data? Suppose if we see one simple example of WhatsApp. So what we are installing is an application that runs on the program which already written on it. So that program is usually stored in the ROM. So read-only memory. So you can't change the program which already installed or already written on it. What is the RAM? So now we are sending the messages, and now we are sending the videos, audios, everything. So those all are the data that could be stored in the RAM. So in microcontrollers, we are having two different memories to store program and to store the data. So such type of architecture which supports this is known as Harvard architecture. So coming to the, sometimes microcontrollers are referred as a computer on chip because everything will be in same single chip. So a microcontroller is having processor, core, volatile or non-volatile memory, and input-output peripherals. So a microcontroller will have input-output peripherals and memory unit along with the CPU. So complete this is can be said as a microcontroller. So coming to the difference between the microprocessors and the microcontroller. So you can say that a microprocessor is a heart of a computer system, because without a processor you are not able to perform any operation. So without processor there is no such applications or no such softwares, no such program, anything. So you can say that without a microcontroller our lives wouldn't be this much easier or this much simpler. Why? So everything we have been using in our day-to-day life will always depends upon the microcontrollers, the automatic things which we are using, washing machines, micro ovens, everything related, everything which we are using on a single purpose devices is used by these microcontrollers. So you can say that microcontrollers is a heart of an embedded system. Embedded system is nothing but which we are hardware and software will be together. So, and in microprocessor, there is only processor, the external memory and input-output device components have to be connected externally. So we have already seen that in 8086 microprocessor, we have externally interfaced the memory and input-output devices to 8086 microprocessor. So here in the case of microcontrollers, the memory, the external processor along with internal memory and input-output components will be there itself in the microcontroller single chip. Since memory and input-output devices are connected externally, the circuits become large. So here in the case of microcontrollers, everything will be internal. So the chip is very small when compared to the microprocessors. So due to these external components, the entire power consumption is very high. So due to its simple everything inbuilt, the power consumption of microcontroller is less. So in each instruction, we need to, if we want to interface any external memory, we need to write the external operation instruction, and this could relatively slower when compared to the internal operation. So in microcontroller, the operations which we are writing, the instructions which we are writing always on the most of the case always on the memory. So can we ask that can't we interface the external memory to microcontrollers? Yes, you can interface external memory. If the internal memory is not sufficient for your particular application, you can interface the external memory to the internal 8051 microcontroller also. In that case, it would be slower, but normally the microcontroller operations are a little bit fast. Why? Because the microcontrollers are designed to specifically for a single application. So specified applications. Once we have written the program for one specific application, that particular chip would always contribute for that specific application only. You can't use that chip to perform another operations. So until the life of the chip's gone, it will be used for that particular purpose only. So where in case of microprocessors, you can rewrite the program, you can erase the program, you can do whatever you want for that particular applications. So here these most of the microprocessors were based upon the architecture of von Neumann architecture, as I already told you in the previous slide, that von Neumann architecture is an architecture which supports the memory the memory which we are using in this particular architecture will have the same data will be stored in the same memory, and the program also will be stored in the same memory. So while in the case of microcontroller, it supports Harvard architecture. So it is having different memory slots. So to store program, it is having program memory. To store data, it is having data memory like RAM and ROM. So these microprocessors are mostly used in the personal computers, whereas coming to the microcontrollers, we have been using these microcontrollers in washing machines, MP3 players. Not only these two, we are using remote control devices like car keys, like everything, remote control devices, operating TV or remotes, everything will be operated using these microcontrollers only. So coming to the block diagram of microcontroller, the internal ROM, read-only memory, so which stores the program, so everything program, and internal RAM, random access memory to store the data, stack pointer to hold the address of the stack register stack, and the registers which will be using for the manipulation, or which will be using to store the data or to process the data using these registers. And there is a register accumulator, it is also an register. So the ALU, arithmetic and logic unit, this unit is performing the arithmetical and logical operations in this particular specification. And here we are having timers and counters in microcontroller to perform specific task within the time. So there are input and output ports to take the inputs and to pass the outputs. So here we are having interrupt circuits to, if there is any interrupt, how many interrupts it can support, how this controller able to encounter the interrupts, like that. And clock circuits, or you can say that frequency oscillator which provides the clock signal. So inbuilt oscillators will be there in most of the microcontrollers. So, and the program counter which holds the address of the next execution instruction. So this is the block diagram of microcontroller: arithmetical and logic unit, a basic registers, internal memory devices, stack pointer to hold the address of the stack, a program counter to hold the address of the program or the instruction which execution next instruction. So clock circuits, which is the crystal oscillator which which provides the frequencies or to provide the clock. And interrupt circuits, input output devices. So coming to the classification of microcontrollers. Microcontrollers have been classified into different types based on their bit configuration, based on the architecture it supports, based on the many things. So coming to the bit configuration. So based on bit configurations, the microcontrollers has been divided into 8-bit microcontroller, 16-bit microcontroller, 32-bit microcontroller, PIC microcontroller, ARM microcontroller. Likewise, there are many microcontrollers based on their bits. So how many bits it can perform in a single clock cycle. So that ALU supports, how many bits of operations can ALU support at a particular clock cycle. So that depends upon the bits. Here we are using 8-bit microcontroller as we are discussing 8051 microcontroller. So basically 8051 microcontroller is a 8-bit microcontroller. It is used to perform simple arithmetical operations or logical operations. So coming to the 16-bit microcontroller, which we can be using for complex computations. Like one of the example of a 16-bit microcontroller is Intel 8096 microcontroller. And 32-bit microcontroller, it is used for automated systems like industrial machines, advanced to for medical devices. So in this particular, we can use this 32-bit microcontroller. ARM microcontroller is used for the movement of robotic arms or legs. So such microcontrollers it will be used for embedded systems also. So coming to the next one, memory configuration. So how memory configurations? Initially, microcontroller 8031 is not having the internal memory. So it requires external storage, external memory interfacing will be required. So embedded memory microcontrollers, most of the microcontrollers nowadays we are using is an embedded microcontrollers, which there is a memory and input output devices, timers, interrupts, all will be in a single chip. One of the most example is 8051 microcontroller. So coming to the instruction set configuration, there are two types of instruction set configurations, CISC and RISC. So CISC is a complex instruction set computer. So the instruction which we are writing is a complex instruction. It takes more than one clock cycle to execute, but the operations will be given in the operations, highest most operations will be performed in single instruction itself. So we're coming to the RISC instruction architecture. So here a reduced instruction set computer, most of its instructions will be executed in a single or less than. So within shorter clock cycles, and these instructions are simple, we can understand by seeing it. So now the another one is overview of 8051 microcontrollers. Nowadays we are using PIC microcontrollers, ARM microcontrollers. So why we need to learn 8051 microcontroller? What is the important thing to learn 8051 microcontroller? So nowadays we are using most of the updated versions of the processors or controllers, but the basics will always be the same. So 8051 is the most commercially successful microcontrollers. The name can vary, name can change, but these whatever this microcontroller we are discussing here, 8051, we are using this because of their cost effectiveness. See, if we want to perform simple application, we are using this car case, right? In that particular car case, there are only 5 to 6 operations to unlock the car, to open the door, to close the windows, like this. 4 to 5 applications will be there, simple process. So for that, we can't use ARM microcontroller because it doesn't require that much supportable microcontroller. 8051 will perform such simple operations. Then instead of using 8051, why we are using ARM? So it doesn't suit, right? So the basics of microcontroller will always start with the 8051 microcontroller, and this is the first commercially successful microcontroller. So coming to the features of 8051 microcontroller, it is a 8-bit microcontroller, so it can perform 8 bits of operations at a time. So one question arises, if I want to perform 16-bit operations, so how this microcontroller will perform? So it can perform 16-bit operations, but it will split into two 8 bits of that 16-bit processor. So it supports, but it need to split it into the 8 bits. Next, it is having on-chip memory. So as I already told you, there are 2 chips. Internal memory will be there. So here it includes 4 kilobytes of RAM, read-only memory to store the program, whereas to store the data we are having 128 bytes RAM. So random access memory to store the program, it can support 4 KB of it can support 4 KB, and to store the data it can support 128 bytes. So coming to the input-output ports, it is having 32 programmable input-output lines. So these 32 input-output lines is having of 4 ports: port 0, port 1, port 2, port 3, and each port is having 8 bits, P0.1 to P0.7. So port 1 is having port P1.1 to 1.7, and here 1.0 to 2.0 to 2.7, and here port 3 to 3.7. All of these ports, each one is having 8 bits of 8 bits input output line. So total 32 pins can be used as input ports, or can be used as output lines, or port 3 is having special functions also. So alternate functions is there, and port 0 and port 2 with combination can access the external memory. So here we are always discussing the internal memory. So it is having internal memory if the application requires more memory than the internal memory. So how microcontroller will do that? So here in the case of 8051 microcontroller, it can support 64 KB RAM and ROM of external memory. External memory. So while we are purchasing mobile phones, they have already inbuilt memory will be there, but they can say they will say in specifications like it is extendable up to 64 GB or up to 32 GB. So likewise here in the microcontrollers also it can be this. In case of 8051 microcontroller, it can support 64 KB external memory, both RAM and ROM. So program memory and data memory. So coming to the timers and counters, here in 8051 there are 2 timers. So each one is having 16-bit timers. Each one is having 16 bits of time delay to provide time delay or to count the number of events performing. So to provide time delay, timers will do. and to count the number of events happening outside the external, so counters will do that particular task. Coming to the communication, serial communication, yes, 8051 supports serial communication by using UART, only universal asynchronous receiver transmitter. In the case of 8086 microprocessor, it supports universal synchronous and asynchronous, but in the case of serial communication of 8051 will supports only asynchronous data transmission. So here we are having transmission and reception of data also. So coming to the interrupts of 8051. In 8051, there are 5 interrupt sources, 2 external interrupts and 3 internal interrupts. So one is a serial communication interrupts, 2 for timer counter interrupts, and 2 external interrupts is there. So clock speed of this microcontroller 8051 is having internal crystal oscillator which provides the clock pulses. So the typical operating frequency of this 8051 microcontroller is 12 megahertz. In precise, you can say that 11.092 megahertz. So this is approximately, but the exact value is 11.092 megahertz. So here we are having power saving mode. It can use ideal mode or it can decrease the power by using to further energy efficiency. So here in Boolean processor, it can do bit manipulations operations also. And external memory support, it can interface 64 KB of external RAM and ROM, as I already told you. So these are the features of 8051 microcontroller. So coming to the applications, where can we use this? These microcontrollers. Basically, microcontrollers. Nowadays, we are using microcontrollers like anything. You name it, that everything will having these microcontrollers. So coming to the washing machines, refrigerators, we are using micro ovens, remote control devices, all. So consumer electronics, which we are using in day-to-day life. So automotive systems, so we have found engine control units, ECUs, airbags, and anti-lock braking system, anti-theft systems. All these are having these microcontrollers. So coming to the medical devices, the pacemakers, glucose monitors, ECGs, EEGs, everything, digitals. So where we are using digital, you can say that microcontroller is there. So industrial automation, it can control, I already told you, controllers are used for robotics, movement of arms of the robotics, and conveyor belts, which we are using in the airports or some other systems. So CNC machines will always use this microcontrollers. Coming to the home automation, so nowadays we are using this home automations by using IoT, Internet of Things. In that particular IoT systems, which is an embedded system, so there also we are using these microcontrollers as hardware units. So coming to the home automations, we are using security systems, automatic on, automatic off, light, everything. IoT based home systems also comes under this home automation. For communication, the most usable thing is mobile phones. So our mobile phones is also having the microcontrollers in it. Routers, Wi-Fi connections, and wireless modules, everything. Wi-Fi connections will comes under this communication systems. We're coming to the aerospace and defense, we are using drones. So nowadays drones become very famous, and we are using some of the service websites also using these drones to serve their customers. So navigation systems, GPS systems, which we are using. So missile guidance systems, all these are one of the applications of microcontrollers. And as all starting, I'm telling that embedded systems. So found in calculators, digital calculators, gaming consoles, joysticks, and digital cameras. So these are all the applications of microcontrollers, and apart from this, there are many applications of microcontrollers is there. So coming to the overview and coming to the until we have discussed about the what is microcontroller, where we are using this microcontrollers, what are the applications of microcontrollers, and what is the difference between processor and a controller, and what is the block diagram of a microcontroller, and especially the features of 8051 microcontroller. Thank you.